Hi, my name is Eduardo Ox, and this is a quite technical talk about EV. So I'm going to suppose that everyone knows what is Emacs and what is EV. The title of this talk is Some Template-Based Functions of EV That Are Not 5-Minute Hacks. And the reason for this title is that when I gave a presentation at the EmacsConf 2020, I gave this title to it, on why most of the best features in EV look like 5-minute hacks. And the last section of that presentation was about one specific feature that I really implemented in just 5 minutes. We can play the video here by executing this link here. It was, just 1 second. Oh, sorry, here. It was part 4. And I explained a certain notion of user-friendliness, and then I explained a function called find-esetkey-links. In this part here, one example. This is one that really took me only 5 minutes to implement. But let's see it in a more technical way. If we execute find-esetkey-links, we get a buffer like this, in which this part here is generated by a template, and if I change these things here by something else, for example, by year in uppercase letters, and I run this line again, then all the buffer is going to be generated again with these values for the things in curly braces. So if I execute this, I get this. Ta-da, this became year. The implementation of this is very simple. It is just a function here with the template here. And the interesting thing is that the thing that allowed me to write this thing in just 5 minutes is that I have a function that generates skeletons for functions like this. If I run this hyperlink here, and note that in the code of find emacs-devel-links, in these comments here, I have a link to this skeleton. If I run this skeleton here, I get a buffer that has this header, this defun here, the optional arguments, and then this field here that is blank. And this field here is a list of temporary variables that I set in a let star. For example, let me change this to full and bar in uppercase letters. If I execute this again, I get this other skeleton here, in which now I have this let star here that sets full and bar to default values. And the indentation changes a bit. If I delete these things and I generate the buffer again, look at this part here, the let is going to disappear, and this thing is going to move a bit to the left, and one of these parentheses are going to disappear. That's it. So to write this function, find emacs-devel-links, I essentially started with a skeleton like this. I had a draft of this thing that I put in the template, and I just moved this thing to the template and put backslashes in the right places so that this thing was going to be just a big string. Because, no, let's look at the source code. If I don't have a backslash here, then this thing becomes a big mess, and not some things that should be strings are not going to be strings, and well, whatever. So this is how I wrote this function, and most of my template-based hyperlink functions. And this one is called find-links new, because it is a successor of a previous version that was called just find-links. That was my function that produced the buffer that would create a skeleton for a find something links, for a function called find something links. But this one was a bit messy, and the new one is quite clean, so I like it very much, and I hate the old one, but I still have the code of it somewhere. I think that I still have some functions that depend on it. Well, whatever. Now let's see one function that uses a template, and its code is quite short, but I think that's a very interesting idea. In one of the sections of one of the tutorials of EV, the one that has number 8 here in the index of the tutorials, is called find-esetkey-intro. And psne is a contraction of something that was already a contraction. This is explained there, it's not important now. And the thing is that psne or psne is a way to download local copies of files from the internet. And it has this example here, where if we execute this, let me change to a smaller font. If we execute this thing here, we create a temporary buffer here that runs a shell, and we set the target of a pitch to this shell here. And now in the lines that do not start with the red star, if I type an F8 here, then the line is going to be sent to the target buffer as if the user was typing that line. And in this case, these 4 lines, they create a directory corresponding to the remote location of this file, I mean to this URL here. It changes its CDs to that directory, and it wgets that file. And it also saves the name saves the URL to a certain log file. So this is the general idea. And then this tutorial explains how I use something similar to this, but much more complicated, to download local copies of files from the internet. Let me switch to a bigger font again. And the new way is by just using meta-x brep. And brep is, the BR in the beginning is the prefix that indicates that we're going to do a variant of browse URL, and this EP means that we're going to run a version in Emacs of something that I used to call psne 20 years ago. If we run this hyperlink here, we get a temporary buffer like this. So it has some variants of how to download this, in which this thing here is changed, and we have code to download a local copy of this URL here, and we have these links here that will let us check the local copy. So we get this. The contents don't matter to us now. My favorite way of running this is by typing meta-x brep, which runs a variant of which calls find-esetkey-links on this URL here. So it's a variant of browse URL in which instead of browsing the URL, we are generating a temporary buffer with it. And this temporary buffer, it also allows us to change the URL if we need to. Let me confirm here. And then we get this buffer here. And usually I just go to this block and I execute this without even thinking. So the rest of this tutorial explains the details, but let me go back. The third template-based function that I want to show is the function that defines this brep, because the brep is a well, let me show this in practice. The brep is defined by this sexp here that uses a template, and this is a variant of code CD that defines this function. It generates a lot of Lisp code as text, and then it reads and eval it, and it generates, in this case, just one function that is based on this function here that operates on URLs, and it defines this function here. And the nice thing is that we can just add this prefix here to the line above to check the code that this thing generates. So instead of executing this code, we are going to just generate the code and show it as Emacs Lisp, which means with nice colors. So this is the definition of brep, and the doc string of it is just apply find-esetkey-links to URL, and it runs blah blah blah. The details don't matter. And the general idea behind these code something functions and their variants that start with find is explained in my presentation in the EmacsConf 2020 in this position here. Let me just show it very quickly.
The code that we saw in the previous section, we can see the code that it produces by making a copy of this line and prepending this string here to the name of the function. So instead of running code-cd, we run find code-cd, and it creates a new temporary buffer with the code that code-cd would execute.
Okay, let me go back. This is explained even in the main tutorial, because code-cd is very important, and the variants of code-cd are important also. So there's a section called shorter hyperlinks here, a subsection that is just about code-cd, and this explanation here, very brief, but it sort of works, of how code-cd works. It produces a big string using a template, and an explanation of this idea of prepending a find to the code-cd to understand the code that the thing generates. And several of my functions that are related to code-cd accept extra arguments. And this tutorial has even a section about these extra arguments using code-cd, that is the main function that users are going to use. And it has some examples. If we run just this, we generate this code here that starts with comments, and then it has several definitions here. It defines a variable and it defines several functions. One of the reasons for using text instead of using macros, by the way, is that by generating text I can add comments, and these comments here have even a Lisp hyperlinks to the documentation. Okay, so this is the code generated by just find code-cd without extra arguments. And if we add an argument here, an extra argument here, the output becomes a little bigger. This section appears, and this section defines a function that opens a node in a certain info manual. And then this thing explains a bit of the nodes and a bit of other extra arguments that we can use. So this was a very quick introduction to this code-cd and its related functions. And again, when I defined brep, I used one of these code something functions, and we can inspect its code by running this. So code brurl find-esetkey-links, etc. executes this thing here. Okay, next section. Sometimes one of the things that beginners often want to do is to define new keybindings. And I realized that I could use the ideas of EEV to provide a different way of doing that. If we just run find-esetkey-links, either with meta-x or with this sexp here, well, sorry, if we run with metax, we get a prompt here that tells us to give a key and then a comment. Let me try meta F5, and then the comment is going to be next line. We get a buffer here that has a big header with lots of help. For example, this line here shows a section of the Emacs manual that explains how to change key bindings interactively. It's not trivial to save these key bindings to your .emacs file after defining them interactively. And these links go to the documentation of these functions here. And these are some calls to these functions that it seems that the Emacs manual suggests people to use interactively. But here we generate sexps for them, both for setting the key and for unsetting the key, and we can save these settings in our notes or even in our .emacs file. For example, I have these key bindings here. When I use the super key, I use super key for several toggles. Here in my keyboard, the super key is the Windows key. So if I use super T, I toggle the toolbar mode, which is this thing here. So let's do that several times. If I use super M, I toggle menu bar mode. I can have both at the same time. I can toggle them very quickly, wherever, but I usually don't like them. And I realized that one thing that I do very often, especially when I recording videos with a big font, is that I toggle line wrap. And I have a function that I've defined ages ago that is called just wrap. I used to call it with just metax wrap. Its definition is here. It's in my .emacs. It's a total mess. And I realized that I could use this define key here to define super W to wrap, and in this case here I'm leaving for reasons that I'm not going to explain now. Instead of setting this in the global key map, I'm setting this in the EEV key map. And if I go here, there's even a link to describe what are the bindings, the current bindings in the EEV key map. So we get them here, and we get the wrap here. So in the emacs-devel mailing list, people are always discussing how to make these things more user-friendly without ever using Lisp, because users should not be forced to see Lisp. And I'm taking exactly the opposite approach. I'm doing everything with the Lisp very evident, with no hidden text and whatevers. And this is an experiment to see if users like this thing. This is very recent. I haven't tested this in guinea pig users yet, so I didn't get any feedback yet. But I think that this can be a good way to teach users how to bind keys, especially because if they type something wrong, they can see what they have typed wrong, and they can see the sexp that corresponds to doing that. They can change the sexp and so on. Okay, this was the fourth thing that I wanted to show. And the fifth thing that I want to show now is how I download videos from YouTube. And this is really far from a 5-minute hack, because this one does lots of magic. And the idea, as always, is that if we twist the notion of user in exactly the right way, then user-friendly and hacker-friendly become very similar to one another. So this is my user-friendly way to download videos from YouTube that is user-friendly to me and maybe to other people, but whatever. The documentation about this find-youtubedl-links is in this section here of the tutorial about how to use audio and video files in AV, in this section here. And the idea is that links to YouTube can have several formats. The long format is this one. There's also a couple of shorthands to this, and they always contain an ID that's always 11 characters long. It only uses certain characters, and I don't remember exactly why, but I decided to call it the hash instead of the ID. So in the code, I refer to this thing as the hash of the video everywhere. And so here in the documentation says how to download the video if you have youtubedl installed. And due to this option here, the video is going to be downloaded with both its title and its this identifier in the local file name. And my favorite way of downloading a local copy is with this function, find-youtubedl-links. Its code is here. Its code is not very ugly, but the thing is that it uses lots of internal functions and variables to discover what is the local file corresponding to the video. Let me show a demo here. I'm going to use a temporary directory for the video, just to not have so much clutter in the screen. Let me switch to a smaller font again. Okay, let me recreate this directory. By the way, I never type these things by hand. What I do is that I just put the name of the directory in a line by itself, and I type meta uppercase R, and I get this. But let's go back to the demo. I'm going to set my favorite directories for videos to this directory here. That's a temporary directory it's not the one that I tend to use. And let me show how to download a certain video. So the hash of the video is here. I just have to place the cursor on the hash and type meta-x find-youtubedl-links. And this function discovers what is the hash around point. Let me type an enter here, and it produces this temporary buffer here. Oops, sorry. Here we have two different functions that regenerate this buffer in slightly different ways. And I'm going to run this script here. Note that it has several variants that run youtubedl with slightly different arguments. I'm going to use the default one. It takes a while. It downloads the video. It's quite short. It's just 10 megabytes. And now I have a video with that name, with this hash in its name. If I visit the directory where I'm downloading the videos, I'm going to see that there's a video with this string in its name. So if I execute this, this sexp opens that directory and searches for the first occurrence of this string, which is exactly in the line where my video is. It is here. So my magic functions have to discover the rest of this file name just by this string here. And if I run this sexp here, that has a new in the place of the title, then find-youtubedl-links is going to try to guess the title of the video from just this thing and the directory. Let me try. Ta-da! It found the right title. Here we have a sexp that concatenates the directory, the title, and the hash and the extension. The magic functions also discover the extension. And if I change this stem here, I get short videos short links to this video. So if I execute this, I get a short link to this video. Let's use the usual trick. If I run this find code cd here, I will get the code that code video is going to run. Let me copy this to my notes. These hashes look ugly. So if I execute these, note that now I have very long lines, so I can type super W and ta-da! It toggles line wrapping. Okay, so if I run this thing here, I get a buffer that shows the code that defines this function here, find-preadingvideo. The problem with reading is something. If I just execute this line here, it defines find-preadingvideo. And if I execute this, I open this video.
In the rest of the significant portion of the play.
In the beginning. But suppose that I've downloaded this video because I discovered that it has a sentence that is a part that is very important. So I took down notes of where it starts and what is the sentence. So I can just make a copy of this that points to the right position.
Of the play where Jocasta, the queen, has no lines. And because we're reading the play, most of us now read the play. Very few of us will have the opportunity, although I urge you to take it if it comes, to see the play enacted. There are some movie versions, and occasionally...
Well, wherever. These are things that I just put here because initially I thought about presenting this in a different order. So this is how I download videos from YouTube in a way that is only user-friendly if I define users in exactly the right way, in which the main user in the universe is me. And the last template-based function that I want to present is find-here-links. This is one that deserves another presentation. I'm planning to record a video about it, but let me present it very quickly. This is one of the main functions of AV. I use it hundreds of times a day because the central idea of AV is that we can keep executable logs of what we do. And these executable logs usually are made half of hyperlinks to interesting things and half of executable code like shell commands or things like that. So this tutorial explained these ideas and then the technical details. And for example, if I run find-here-links here, note that it is bound to meta h, and when I type meta h, it generates a temporary buffer with links to here. Here is a header with help, and here is the link that I want. A link to the tutorial in which I was. And I want to show something that is not very well documented yet, that is a way to create a different way to create links to video files, audio files, PDF files, and so on. And it is explained in this section of the tutorial, but I don't think that I've revised it enough times yet, so it may not be very readable. And the idea is that if you type meta e, then this runs find extra file links, and this is an experimental feature whose behavior may change soon, but here is how it works now. And here is an example in Lisp. If we execute this, we get a temporary buffer with several kinds of hyperlinks, including code CD, code video, etc., pointing to this file here. So this block here supposes that this file is a PDF file. This one supposes that it is a video file. And I can use this stem here to generate functions that have this string in their names. And let me show a more realistic example of how to use this, which is, let's go to the directory where I've downloaded this video file here. If I type meta-e here, I get a buffer that lets me define several kinds of links to this file. This file is a video file, and let me use this string to identify it. Let's use
occasionally you'll run across,
what I did.
an acting company that will produce this on a stage. But most of us will read this play. That's what you'll likely be doing as well. And so you have a problem. Remember that a playwright does not write the script to be read. What we're doing is not what the playwright wanted us to do. Shakespeare, for example, writes his plays. What he's making.
Sorry for the mess. I played this as an audio, and there's no very easy way to stop it.
That's for the actors. And most people in the modern age read the scripts and think we're getting Shakespeare. We're not.
So if I run this, now I've defined these short links here. We'll find pread video, and if I execute this,
in the rest of the significant portion of the play,
then I get this is a link that points to that video. Okay, so sorry for the mess, and these were the things that I wanted to show in this presentation, and that's it. Bye!